Good afternoon, everybody. Thanks for coming on such short notice. I'm Doug Crockford of Yahoo. Today, the tale of JavaScript, ECMAScript. I'd like to take a running start at these things, so we're going to start with HyperCard. Anybody remember HyperCard? Okay, the old-timers are raising their hands. So HyperCard was a program developed by Bill Atkinson at Apple Computer. He was well known at the time for having done QuickDraw and Mac Paint. And he came up with a database application program that was real easy for non-programmers to use. At the time, professional programmers were having a difficult time writing applications for the Macintosh because they had trouble understanding the event-driven model. HyperCard just took that and made it really simple and straightforward. And so it was very popular. There was, at a time, talk about stackware taking over the software industry. That didn't happen for a number of reasons. But HyperCard was very influential. It had a small number of object types that it allowed users to create and manipulate. A stack, which was a container of backgrounds and cards. A background, which was an image, which could also have buttons and fields on it. It could have cards, which would have a background and buttons and fields, and a button, which was some text or an image that you could click on, and a field, which was a rectangle that contained some text. Real simple structure, but very flexible. You could take any button or any of those objects and open it up and give it a name and specify behaviors for it. And one of the things you could do is give it a script. So if you clicked on the script button, then another window would open up, and then you could start playing with it. And most of the scripts would be written in the form of event handlers. So you'd say something like on click or on mouse up, you do some stuff. It used a language called HyperTalk, which was sort of English-like, and that was one of the things that made the system easy to learn, but also just the whole notion was simple and powerful. It was really, really effective. So you had stacks of cards containing images, buttons, and text fields. At any time, you see one card in a stack, but by clicking, you can move to another card or move to another stack. It didn't anticipate color, possibly because Macintosh didn't have any color at that time, possibly because Bill was colorblind. It didn't have text links, so you could click on a field and go somewhere, but you couldn't click on a particular word or group of words in a field and go somewhere, or at least not easily. And it didn't anticipate networking. So the distribution of stacks was done the old-fashioned way, usually on floppy disks or some other medium. The notion that you could click on something and go to the network and find something hadn't really been understood yet. But it was still a very influential model, and it had a big influence on Tim Berners-Lee at CERN. So things like home pages came from the notion of the home stack that HyperCard had. But in a way, the World Wide Web was a much less ambitious thing. At that time, it was intended to be just very simple documents containing text links. Clicking on a link would take you to another one. The World Wide Web had an influence on a group of students at the National Center for Supercomputing Applications at the University of Illinois at Urbana-Champaign. And they built a browser called Mosaic, which implemented World Wide Web and Gopher and FTP and a whole lot of other protocols. And they call it Mosaic because it was made up of all of these different things. They didn't know which of those was going to win the information retrieval race, so they figured, let's bet on all of them. And so they built something that worked with all of them. But the one that won was the World Wide Web, and it was because they added to the original specification of HTML the image tag. That was a very controversial addition, and they didn't seek anybody's approval in doing it, they just did it. And in doing it, they allowed a web page to look like anything you wanted it to look like. So even though the web couldn't do everything you wanted, it looked like it did everything you wanted, and that was enough. So Mosaic became very popular and started to become interesting to the mainstream. That got the attention of Jim Clark, who'd been one of the founders of Silicon Graphics. He convinced some of the kids from the Mosaic project to go work for him at a new startup, which eventually became Netscape. At Netscape, they were building a bigger browser, and they realized early on that document retrieval was not all there was going to be. There's also going to have to be distributed computing. And they wanted it to work along the same lines as HyperCard, because HyperCard was really easy, and they wanted something equally as easy for people to use, thinking if they could make it easy enough, then they would get a lot of acceptance for it. So they hired a really bright guy to do that work for them. This guy, Brendan Eich. He came from Silicon Graphics. When he was being interviewed, he told them that he would like to write a scheme interpreter. And they said, wow, that's great. That's just the kind of thing we're thinking of. So they hired him, but before he started work, they found out what Scheme was. And when he got there, they told him, don't do Scheme. We want something that people are going to like. So make it look like Java, Visual Basic or something. Don't do anything with all those parentheses. We're serious. We want people to like this. So Brennan started to work on a different language. And so what he did was he took the syntax from Java. He took functions, or lambdas, from Scheme, first-class lexically scoped functions, and he took dynamic, prototypally inheriting objects from Self. Self was a really interesting language which grew up from the Smalltalk community. It observed that classes in Smalltalk were just too complicated, and that you could actually make the language more powerful by removing classes and having objects inherit directly from other objects. It was a really powerful insight. Brendan had read those papers and was influenced by him. So he combined elements of each of these three languages. It was kind of audacious in something that was supposed to be so completely commercial to be taking features from two commercially failed languages. But he did that. And apparently nobody else at Netscape was paying any attention. So it was interesting to him, so he did it. He took about 10 days to design and implement the prototype for the language, which is an astonishingly short amount of time. Netscape did extremely inadequate testing of the language before they released it on the public. So as a consequence of that extremely compressed time scale, it went out with a lot of bugs in it. But it was given a name, and it did get out. It was called LiveScript. And it was included in the Netscape 2 browser, and it was also included in their LiveWire server. So server-side JavaScript was going on back in the mid-90s. It disappeared later, and maybe I'll tell you why. So at the time, there was huge excitement around Netscape because it looked like that browser was going to allow applications to escape from the Microsoft operating system platform and liberate programs so that they could run anywhere and break the Microsoft monopoly. At the same time, Java got a huge amount of attention for exactly the same reason. And the people at Sun and the people at Netscape reasoned that they needed to work together to topple Microsoft, because if they worked individually, Microsoft would play them off against each other and they would both lose. The biggest point of contention was LiveScript. They agreed that JavaScript should be put into the Netscape browser, but they couldn't agree on what to do with LiveScript. Some thought it was obvious. You just kill it. Because everybody knows that Java is the language of the web, and there is no other language necessary. At Netscape, they saw it differently. For one thing, they had just built a DOM, a primitive DOM, and it didn't have any interfaces that talked to Java. It only talked to LiveScript, and they didn't have time to rework those interfaces. So they said, we need to keep the language in there to act as the glue between Java and the browser. That still didn't satisfy Sun, and then I think it was Mark Andreessen, and I think as a joke, suggested that they change the name of the language to JavaScript. The thinking was that if he called it JavaScript, then Sun couldn't hate it. And apparently worked. That resolved the impasse, and they went ahead on that basis. They had a joint press conference in which they declared, we have this new language, except they misrepresented what it was. That it was a stripped-down Java. It was greatly simplified, not a real programming language, but still had an important function within the browser. And so as a consequence of that intentional mispositioning, it was many years before developers figured out what the language actually was. At that time, Sun claimed ownership of the trademark, even though Netscape had done all the work and come up with the name, because Sun figured that they owned anything that had the letters JAVA in it. So they took ownership of the trademark and they gave Netscape an exclusive license to use the trademark, and Netscape was satisfied with that. Meanwhile, at Microsoft, they were blindsided by all this web stuff. At Microsoft, what thinking at the time was that the future was going to be either CD-ROM or fax or Windows-based cable set-top boxes. And they hadn't considered that the web was going to become anything important. And so, blindsided, they decided they needed to get into the browser business. So they scooped up the rest of the Mosaic kids and started making browsers. And they also very carefully studied what Netscape had done in Navigator 2, including what they had done with JavaScript. They did an extremely careful job of reverse engineering the JavaScript engine, copying with amazing fidelity a lot of the really awful bugs that had been put in it in haste. And because of the trademark problem with Sun, they were not getting along with Sun very well at that time. They didn't seek to get a trademark. So they just called it JavaScript, hoping to avoid any problems. So it was now the J word. They did a similar thing with their implementation of Java. They called it J++, because we just don't say Java around here. Netscape saw that and was alarmed. Oh no, we're going to get embraced and extended. We need to make a standard out of this so that Microsoft doesn't run away with it. So they went to W3C and said to W3C, we need a standard, so please do this. Now, it turns out W3C had been waiting for a long time for an opportunity to tell Netscape to go to hell. So they told Netscape to go to hell. So Netscape shopped around and eventually ended up at the European Computer Manufacturers Association, which is sort of a long way to go for a California software company. But that's where they went, thinking they could get a rubber stamp patent. It turned out it didn't work out that way because Microsoft joined the patent or the standards committee, and so Netscape did not get its way on every issue. One of the points of contention on the committee was what to call the standard. Netscape said you can't call it ECMAScript, or you can't call it JavaScript. Only we can call it JavaScript. So they kicked around a lot of other names like WebScript and NetScript, and they couldn't agree. So eventually it got published under the working title, which was ECMAScript, which is maybe one of the worst names ever given to a programming language. Not that JavaScript was a great name either, because it's completely confusing, but that's what happened. Then Netscape self-destructed. Turned out they didn't have a business plan. Well, they had one, but it didn't work. Their plan was that they were going to make a browser, give it away for free, and once everybody was hooked, they would charge everybody $30 for it. And if you multiply $30 by everybody in the world, that's a good return. But Microsoft, when they saw, oh no, we have to compete against these guys, followed their model, said, okay, it's free. We don't care. We're selling operating systems. So that made it impossible for Netscape to ever charge for the thing. They raced around looking for other sources of revenue, including servers and services and sites, and nothing worked. So eventually they went bad. They shipped crap, and they ran out of money, and that was the end of Netscape. At that time, Microsoft said, okay, good, the web's done. We don't have to waste any more time on that. We can get back to doing set-top boxes and other important things. So they dismissed the IE team, reassigned them to Avalon and other projects, and moved forward. Now, one of the reasons why they did that was because of this guy, George F. Colony, who was the chairman of the board and CEO of Forrester Research. In 2000, he predicted that the web was just about to die. He said another software technology will come along and kill off the web just as it killed news, Gopher, and everything, and that judgment day will arrive very soon in the next 2 or 3 years. He was pushing something called X-Internet. And his thinking was that document retrieval was not going to be the important thing going forward. It was going to be distributed computing, which turned out to be true. But his mistake was in dismissing the web. Microsoft, though, accepted his opinion and assume that the web was done. Now, before leaving, Microsoft had developed JScript, which was a high-fidelity clone of JavaScript. Had they not done that, we wouldn't be talking about JavaScript today. I mean, ECMAScript. They generalized the document model. The DOM that Netscape came up with was quite awful. And that's really saying something when you look at how awful the modern-day DOM is. But Microsoft significantly improved the DOM, made development much less painful. And they also developed the XML HTTP request so that we could have data interchange going back and forth, which is a necessary condition for distributed computing. So having done those things, Microsoft declared victory and left the field and declared that the browser war was over. Then suddenly, 5 years later, Jesse James Garrett in the shower discovers Ajax and realizes that all of those things Microsoft put in there intentionally for the purpose of creating interactive distributed applications could be used for interactive distributed applications, thus blindsiding Microsoft a second time. So Netscape, or JavaScript should have died with Netscape. There are lots of companies who created proprietary languages. They fail, the language is forgotten. That didn't happen this time. The Ajax revolution succeeded because of the goodness of JavaScript and because of the good works that Microsoft had done. So Microsoft had actually sown the seeds of its own frustration here. Another thing that happened was with Ajax, the source of innovation shifted from the web makers to the web developers, primarily in the form of Ajax libraries. During the browser wars, the two combatants would tend to ship updates at a pretty frantic pace. But that came to an end when the mainstream adopted the web. Early adopters are happy to load a new version of the browser every week to take the bug fixes, whatever. The mainstream isn't. They just want to click on the E and get to the internets. So once your parents essentially got onto the web, that was it. It was no longer possible for the browser makers to compete because there was no way they could get enough people to pick up the next version of the product to make any difference. So it was the Ajax libraries which had the advantage of being able to update immediately, who mined all of the features of the browsers and found a way to make it powerful and useful. It turned out a small amount of JavaScript can transform the DOM, which is one of the world's awfulest APIs, into something that is pleasant and productive. JavaScript is that powerful that it can do that. So as a consequence, Ajax libraries are fun and easy to make, and that's why there are a lot of them out there. I've made 6 of them myself, and there are lots of other people out there making very good ones as well. They all work differently, but almost all of them are quite good. So as a consequence of Ajax and JavaScript getting a second chance, it has become the world's most popular programming language. I mean this in that there are more people writing JavaScript today than any other language. And there are more JavaScript language processors running on more computers than any other language. It's not only in the browser, it's in desktop applications, it's in operating systems, it's in databases, it's in servers, it's all over the place. At the same time, JavaScript is the world's most unpopular programming language. And this is in the sense that if you take a poll of any group of programmers and ask them, what language do you hate the most? Overwhelmingly, the most popular answer is going to be JavaScript. And it'll probably be fairly evenly distributed over people who use it and people who do not use it. There's no other language which has this same extreme of popularity and unpopularity. It's unprecedented. So there's some reasons that people have for hating JavaScript. One is that it has bad parts, and this is absolutely true. Because it was shipped in way too little time, it was rough and buggy, and most of those bugs got put into the standard. So the standard demands that implementations of JavaScript be buggy. Fortunately, it requires them all to be buggy in the same way. And for the most part, all the browsers comply with that. So even with these defects in the language, portability is quite good. There's a complaint that the DOM is awful, which is absolutely true and has nothing to do with JavaScript, because JavaScript is not the DOM. If you were to take your favorite programming language, remove all of the standard libraries, replace them with the DOM, you would hate that language. And that's what happened to JavaScript. There's a complaint that it isn't Java or C# or C++ or Python or, pick any language. There's a lot of resentment among people that I don't want to have to use JavaScript, and I resent that I have to learn the language. So since I have to use it, I'm not going to learn it. I'm just going to use it without learning it, and like that's harming anybody but themselves and their users. And then there's a complaint that it didn't die. It should have died. I mean, Java was in the browser, and it failed bad. It was one of the worst failures in the history of programming languages. It was out there in public where everyone could see. And for the most part, the Java community has tried to completely forget that applets were a total failure, that the thin client was a total failure. It was a total, complete failure. Why didn't JavaScript fail? I mean, it's not fair. It didn't, and they think it has a lot to do with luck. And certainly there is luck, but the fact that Java failed and JavaScript succeeded, I think tells us that there's more going on there. So there are reasons to like JavaScript, because it has good parts. There's actually a lot of good in JavaScript. If you scrape away the obvious bugs and badness, there is brilliance in this language. It scales from beginners to masters. We've got people who don't even know that they're programming, who are cutting and paste and being productive in this language. We've got computer scientists who are doing important work in this language. Reaching either of those extremes, either of those audiences, is really hard. I mean, that's an amazing language that can address either of those groups. And to reach both with one language is extraordinary. It's a huge accomplishment. So let's look at some of the things we get in the language. We have a number type in JavaScript. And JavaScript is interesting in that there is only one number type. There's no integer type. Some people think that's a bad part. You need to have at least 8 or 9 number types or you're not a real language. It turns out having just one number type is a really, really good thing. It greatly simplifies the programming model. It avoids number wraparound and overflow issues. It avoids type coercion issues. It makes the language a lot easier to learn and use. Brilliant thing. It turns out the original BASIC, Dartmouth BASIC, had one number type, very similar to JavaScript. That was right, but it was not influential. Even later basics that came after it larded on a whole bunch of additional number types to no good advantage. The one problem with JavaScript is it chose the wrong number type, which was IEEE 754, which is the world standard floating point standard. It's quite awful. And it's hard to criticize JavaScript for having picked that one because virtually every programming language developed in the last 20 years made the same mistake. It's a very popular mistake. It's hard to find a language which did not make this mistake. So JavaScript doesn't have ints, and a lot of programmers come to it and go, well, how can you do anything without ints? Well, it turns out ints, as implemented in most languages, since Fortran, C, and everything else, has this defect in it where you can have A being greater than 0 and B being greater than 0 and add them together and get a result which is smaller than A and smaller than B. This is insanity. How can you ever have any confidence that your program's working correctly if this is a possible result? JavaScript does not suffer from this because it does not have ints that wrap around, and that's a huge advantage. In any computer system, the associative law does not hold. Just because numbers in a computer have to be finite, but real numbers don't. And so you're always going to have conditions where you cannot represent something accurately, and so the order in which you do things can produce different results. JavaScript implements integers as floating point values. And as long as your integer is smaller than about 4 trillion, it works perfectly. When you get over 4 trillion, then you kind of enter the twilight zone. So if you add 1 to a number that's more than 4 trillion, there's a chance that you get the same number back, that the 1 acts like a 0. And that's kind of crazy too, but it's not as crazy as it suddenly turning negative or doing something weird like that. The big problem with JavaScript numbers is that it cannot represent decimal fractions accurately. And again, this is the IEEE problem. It's a binary floating point system, and it cannot accurately represent decimal fractions, which is a problem only because we live on a planet where the major inhabitants of the planet use the decimal system. And it's especially a problem in applications that deal with money, because when you're adding people's money, they have a reasonable expectation you're going to get the right sum. And when you're using this number format, you often don't. And that is a huge problem. So we have objects in this language. We have a brilliant representation of objects. In this language, all values are objects with the exception of null and undefined. Everything else, strings, numbers, booleans, they're objects. Arrays are objects. Everything is objects. Functions are objects. An object is a dynamic collection of properties. And each property has a key string which is unique within that object. And they're completely dynamic. So you can get any property that an object has simply by asking for it. You can add or replace properties simply by assigning to it, and you can delete properties from an object. So every object's like a little database, a little hash table, wonderfully expressive, powerful notation. Using JavaScript correctly, you don't care what an object's lineage is. You only care about the character of its contents. You don't care about what it inherits from. You only ask, what do you know how to do? And it'll do it for you. And reflection in the language is really easy, so that's an inexpensive question to ask. Objects can inherit from another object. This is sometimes called prototypal inheritance or differential inheritance, in that when you're setting up an object, you only have to specify how it is different from the object that it inherits from. That's sometimes also called delegation, where an object can say, anything I don't know how to do, ask that object to do it for me. So the system is class-free, and for people who come from classical languages, this is alarming. Where are the classes? Where are the constructors? How do you make stuff? It turns out it's liberating. It is a much, much easier way to create applications. It turns out it's easy to build classical systems using a prototypal system. It's really hard to go the other way. If in a classical system, try to write something prototypally, it just doesn't work. And the reason is that the prototypal system is much more powerful. For years, we were told that it was much less powerful, that it was deficient, it was an oversimplification of the classical model. It was never that. It was an advancement over the classical model. And JavaScript is the language which brought this to the mainstream. It has much more expressive power than the classical system. So if you're using it well, programs will tend to be significantly smaller than they would be in an equivalent to classical language. We have object literals, an amazingly brilliant way of creating objects and specifying their contents. I happen to know for a fact that they were the inspiration for the JSON data interchange format. Don't ask me how I know. I just know. Brilliant feature. We have Booleans, and you'll be happy to know that we have two Boolean values and they're true and false. Not all languages got that right, but we did. We have strings, which are immutable sequences of characters encoded in Unicode, which is exactly the right way to do it. We have a date function, which was based on Java's date class, which was not Y2K ready. I guess when they were putting it together in 1995, they didn't see what was coming. Maybe they didn't think it was going to last that long. They eventually fixed it. We've got regular expressions. This is a regular expression that matches regular expressions. At least I claim so. I actually have no confidence that it actually does. You can't read them. They don't make any sense. They're really hard to parse. They're really hard to have any confidence that they're matching what you think they're matching. And it really scares me that people use them for input validation for security purposes, because how could you know? But they're popular, and we've got them. We have loose typing. This is a controversial feature. I think this is one of the good parts. A lot of people think it's one of the bad parts. The fashion in most languages today calls for strong typing. And the advantage of strong typing is that it allows for the compiler to detect a large class of errors at compile time. And the sooner you can detect an error, the less it will cost over the life cycle of the software. And that's an extremely good thing. Except that it turns out that having type checking does not relieve you of the burden of having to test. And it turns out there's an even larger class of bugs that type checking doesn't find for you, so you still have to test a lot. I used to go to the church that said strong typing was the way to do it. But working with JavaScript, I discovered that my testing burden is about the same. And the amount of bugs that, or the bugs that a type checker would have found, I tend to find those really quickly anyway. They end up not costing me very much. And the bugs that keep you up at night, type checking really doesn't help for those. On the other hand, programs are a lot easier to write. You don't have to declare the types of things anywhere. You never have to cast. You don't have to classify and build a taxonomy and try to get that working right. That's really hard to do. So the task of programming is a lot simpler. So I think this is a big win. And here's the best part. We've got functions. The way we have functions are based on schemes lambda, which is wonderful, where a nested function enjoys the context of the function that it's contained within. This has endless opportunities for doing really expressive things. So functions are first-class objects, lexically scoped. This is much richer than the instance class package hierarchy that you've got in most classical languages. You can nest these things as deeply as you need, or as shallowly as you need. You're not stuck with this rigid three-tier hierarchy. And functions are much easier to write than classes. They're much more expressive, really great things. So what is JavaScript? JavaScript is a functional language with dynamic objects and familiar syntax. That's all it is. And that turns out to be an amazingly wonderful set of features. JavaScript, because of its functional nature, is especially effective as an event-driven application model. And that's a good thing, because when we're writing UI applications, that's what we're doing. And it turns out writing interfaces in AWT is really horrible. And writing them in JavaScript is easy and pleasant. It's about the same level of difficulty as writing in HyperCard, which beginners can do. And with the right Ajax library, beginners can do it really easily. Programs written in JavaScript can be significantly smaller than equivalent programs in other languages. But in order to get that efficiency, you have to learn to think in JavaScript. JavaScript has so much expressive power in it that you can program it as though it is a different language and actually be successful doing that. But in doing that, you will be suboptimal. So if you want the best results from the language, you need to think in terms of functions and closures and dynamic objects, because that's what it's really about. That's what it's good at. And when you use it that way, it's an extremely productive language. So there are a lot of problems in JavaScript, and I think the most effective way to make JavaScript a better language is to remove the good parts. Now, it turns out ECMA is unable to remove the good parts, or unable to remove the bad parts. And the reason for that is that the bad parts are not useless. They're just dangerous and hazardous. So there are clever people out there in the world who have taken great advantage of all the bad parts. And we don't want to break even their programs, even though maybe they deserve it. So we have to keep a lot of the bad parts of the language. They'll probably be there forever. But that doesn't mean that you have to use them. You have a power that the standards body does not have, in that you can use the fraction of the language that makes sense. And so toward that, I wrote a program called JSLint, which identifies the good parts and bad parts in your program. And it will sometimes tell you things are bad, which other people will tell you are good. It turns out JSLint is right. So if it tells you something's bad, you should take a hard look at it and figure out how to make it better. The standard for JavaScript is called ECMAScript, and this is a recent history of the standard. What's running in the browsers today is the 3rd edition, which was published in 1999. Late last year, we finally approved the 5th edition. We think it's a good idea to rev it every decade or so, just to keep it current. The 5th edition actually defines 2 languages. The default language, so if you're just using ES5, that's what you get. And there's also a strict language that you can opt into. And the strict language was created specifically for applications that have a greater need for security, because there are a lot of hazards in the current language, and many of those are corrected now in the strict edition. And in the future, the next edition, if there's a sixth edition, will be based on the strict subset, not on the default language. So if you expect your programs to have any longevity, you want to be working in the strict subset going forward. So in the short term, I recommend that you be working in the intersection of ES3 and ES5 strict. That intersection will work in all the current browsers and will work going forward. In the long term, you should be working in ES5 strict. There may be temptations to be working in ES5 default. I recommend you resist that. So what's next for this silly language? We're working on a new edition of the standard, which we expect might be done in 2 years. And we're looking at a lot of things. We're listening a lot to the community and trying to figure out what people want. One of the things people are asking for is a better target for compilation. One really surprising outcome has been that JavaScript has become the world's virtual machine. People are taking other languages and translating them into JavaScript. We thought that the Java VM or the CLR would have that role. It turns out, no, it's JavaScript. People are compiling Java and other languages into JavaScript because JavaScript has a lot of really nice properties, including its ubiquity and its availability and its reliability. And for some applications, it's significantly faster than Java, particularly starting programs up, which is a big deal when you're sending programs in front of people. So one of the difficulties for people who are doing that is sometimes JavaScript is not a good match for the language that they're trying to compile from. Say you've got a language which has some control structures that don't map directly onto JavaScript's control structures. What do? You have to do a lot of weird things, like maybe generate programs that are huge case statements and jump through cases, which is an awful thing to do, but so they'd like to not have to do that. So we've been asked a number of times, put goto into the language, and that way we can generate our own control structures. Assembly language has a jump statement. We need you to have a jump statement. The old-timers will remember many years ago, Dijkstra wrote a letter to the ACM in which he said, there's a problem with the goto statement. People write bad programs when they're using the goto statement. We should figure out another way to do this. And we spent literally a human generation, arguing about goto. And in the end, we finally decided that, yeah, goto is a bad thing. We should stop using that and go to higher level structures like while statements and if statements and stuff like that, which we did. If we were to now put goto back into the language, absolutely certain there are ninjas out there who will go, oh, I'll bet I can make my program go faster if we use the goto. We can't put it in for one group and expect another group not to do it. And we think it would be shameful to cause that kind of regression. So we're not going to do that. Our first responsibility has to be to the web and to the principal users of the language. Secondarily, we'd like to help out the people who are using it as a compilation target, but they have to be second priority. There's a lot of demand for an intermediate representation. Most languages will produce an intermediate file, like a class file or an object file or something like that. And a lot of people would like JavaScript to do that. The way JavaScript works today is you send the source file to the execution site, and it gets compiled and executed there. The idea is that if we had an intermediate representation, we'd have better security, and it would be faster because you don't have to compile at the execution site. Both turn out to be wrong. The idea that you can hide anything in code is just wrong. So if you think you can put passwords or secret codes or secret algorithms in code and compile it and then no one will ever figure it out, that's just wrong. And so anything which encourages people in that false belief is going to be counterproductive. Then one of the things that caused Java to fail in the browser was that it took so long to load classes. And that's because they had to reconstruct basically what the source code said in order to understand, is stack discipline being maintained? Are all the references in the code doing something equivalent to what is allowed by the language that it's trying to execute? That took so much took more time than compiling the thing in the first place. So that's not going to speed JavaScript up. If we want to make JavaScript compile faster, probably the best thing we could do is remove features from the language which make compilation difficult. And that's probably a worthwhile thing to do, and maybe we'll figure out how to remove things in some future edition. There is one good reason maybe to have an intermediate representation, and that might be for macros. There's still a lot of pressure on the language to get classes, even though we've sort of transcended classes. A lot of people haven't caught up with that idea yet who'd like us to dumb the language down and make it more familiar. And we're thinking we probably can't do that in a way which is going to be satisfactory to everybody. But what we could do is provide macros, and then anybody who wants to write their own class structures could write macros that would do that. And one attractive way of doing macros would be to give the macro access to the abstract syntax tree that was compiled from the tokens that the macro is going to operate over, allow it to mutate the abstract syntax tree, and then we send the syntax tree to the code generator. So that would give macros a huge amount of power in deciding how the language should work. We haven't worked through the details of that, but that's something we're considering. A lot of people have been asking us for threads, and I'm confident this will never find its way into the language because threads are evil. Now, it turns out threads are sometimes a necessary evil, particularly if you're writing at the system level. In device drivers, they're sometimes useful in operating system schedulers, places like that. Yeah, you have to have threads. In applications, no. Threads are really dangerous. They make it difficult to reason about the correctness of programs. They put a much too large burden on the programmer that you have to insert locks and synchronization code into something just to make sure that you don't have real-time interactions. Makes debugging much, much harder. Not many people can reason well about threads, so I think we shouldn't have them. I think Java made a mistake in making threads available at the application level. Java couldn't decide what kind of language it wanted to be, a system language or an application language. And there is a lot of interest in having a single language which does everything. I think that's a mistake. I think specialization is a really good thing. And keeping your system languages and your application languages separate, at least, I think is a really good idea. So no threads. What we are likely to see is more use of processes. We have a process is like a thread with its own memory space. That turns out to be an extremely reliable structure, makes very good use of multi-core architecture. Having that with a messaging system that allows for communication in between them using something that looks like events is a very good match for this language. We'll probably see a lot more of that in the future. A lot of people ask us, can you make it more like some other language that I use? And there are a couple of motivations for that. One is, I know that language, and I don't know this one, and I really don't want to learn this one. So if you made it look more like that one, then I'm set. We're probably not going to do that. We kind of like this language now, and we're pretty confident that if we throw the kitchen sink at it, it will get worse. Particularly as we're thinking more about security, simplicity is our friend and complexity is our enemy, so we don't want to be doing that. We will be considering individual features if those features can prove that they are clearly worth it. If they are hugely expressive, so that if we add this little thing you can save 10 lines of code, that kind of stuff, yeah, we'll definitely do. Or if it makes the program significantly easier to read so that a reader can pull the understanding of the program out more readily, those sorts of features definitely we'll consider. Things that are just cool, I'm hoping we'll be able to resist doing that because there's not much payoff in coolness. So security is the big thing. We hear a lot about cross-site scripting attacks and other security hazards in the browser. And there's a concern that JavaScript has a lot of security holes. And it does, and they need to be fixed. But there's some good news on that front. Because of its Lambda nature, JavaScript is already close to being an object capability language. It comes closer to being a secure language than almost any other language in current use. And just a small set of changes will turn it into a completely safe language. We moved a little closer in ES5 strict. There are still problems, but we know what they are and we think we know how to solve them, primarily around the global object. The global object was something added to JavaScript because Brendan didn't have time to think about how to do a linker. So a program could be made up of many compilation units, and how do you get them together so they can communicate? He just put them all in a common global object and let them sort them out. And that turned out to have terrible reliability problems. It is the root cause of cross-site scripting attacks. So we need to get rid of that. And having done that, JavaScript almost completely turns into a safe language. It's kind of extraordinary. There's still the problem with the DOM. So the motivation for doing this is mashups. We want to have components which can represent multiple interests that can work cooperatively for the benefit of the user without compromising each other or the user. We can't do that currently. So we've seen a lot of demonstrations of mashups, and they're wonderful, but if there is any confidential information on the page, then compromise can and probably should be expected to occur, and that's unacceptable. So we know how to fix it, and we'll probably see that in the next edition of ECMAScript. So once we do that, the last remaining problem will be the DOM. The DOM was not created with any expectation of security, and so every node is connected to every other node. So if you can get access to any piece of it, you get access to everything it knows, and that gives you access to the network. So any information you find there, you can send anywhere in the world. And also, because you have access to the whole page, you can do things like ask the user, what's your password? Say, and if the user is looking at the anti-phishing Chrome, the anti-phishing Chrome will say, this is a legitimate request, so you should give it up. So we need to fix that, and the DOM is now in the way of that. Unfortunately, HTML5 is a big step in the wrong direction. They have intentions to fix security problems, but they're not actually doing it. And by increasing significantly the complexity of HTML and the browser and the DOM, they're actually making things worse. I don't know how we're going to resolve that. I don't know if we have to wait till HTML6 or what. On the good news, ECMA and W3C had their first ever meeting last November. It's kind of amazing, but those two organizations have never talked before. And they have a lot to talk about. We need to work together to make the language and the DOM fit in a way which is safe going forward. So at the last meeting was very successful. We agreed that we should have another meeting, and we'll do that. We'll keep you posted. So Ajax has become the dominant application platform. Against all expectations, against all predictions, that is where most applications are going today. But there's a problem with it. The Ajax community has mined all the latent potential of the 20th century browser platform. And we're at the point now where we cannot advance anymore without advancing the browser itself. And there's good news and bad news there. The good news is that all the browser makers are happy to go, and even though HTML5 is terrible, there is some good in it, and it's good to go forward with it. But there's still Internet Explorer 6. Now, for many years, IE6 was the very best web browser in the world and remained the best web browser in the world for many, many years. Is that a surprising statement to anybody? Everybody knows that? More recently, it's become the worst web browser in the world simply because it has not aged well and should not have been left in the wild for this long. And it's only the worst if you don't count anything that Netscape ever did or a lot of other stuff. Netscape 6, or I'm sorry, Internet Explorer 6 is fading very slowly. 5 years ago, I predicted that it would probably be gone in 5 years. That was wrong. That estimate was based on how long it took Netscape 4 to fade away after Netscape failed. IE6 is holding on much longer. It is lingering, primarily because we're doing such a good job of supporting IE6 that there's no reason for those users and the companies that are stuck on it to move off of it or to consider other options. And it's going to get worse as we add new features to ECMAScript, as we add new features to HTML, because you're going to be expected to use all those features to do wonderful things in order to be competitive and to make them work on IE6, which is impossible. And so you're going to have to be finding amazing workarounds. It's going to be bad for the developers going forward. Now, I can't tell you what the exact numbers are, but I can tell you this truth. There are more obsolete copies of IE in use than Opera, Safari, and Chrome combined. So when you're sitting around wondering what browsers do we want to support, if you can make the case that you should be supporting Safari and Opera and Chrome, and you should, it's really hard to also make the case, and we shouldn't support IE6 because its numbers are huge in relation to those. But as long as IE6 is out there, it may be years before you can safely and conveniently make use of the features in the new browsers. And that's just unacceptable. We need the new support from the new browsers, but we cannot make effective use of the new facilities and support IE6 at the same time. So, IE6 must die. It was announced this morning that IE6 was dead. It's not dead yet. It's still out there and it's still way too strong. The thing that we could do to kill it is to redirect. If anybody comes to our sites and says, I am on IE6, we say, sorry, and send them to a page where you can pick one of 5 wonderful free modern new web browsers that you can download and use for free. All you have to do is click and say yes. At this point in time, nobody wants to be the first one to do it. Nobody wants to say to the IE6 community, please go to my competitor and take your business with you. Nobody's doing that. So Microsoft, for example, has a huge interest in getting rid of IE6. They really do. But they're not going to say, stop using Bing, go use Google for a while instead. Nobody wants to do that. So somehow we need to figure out a way that everybody on the same day and date will say, today, worldwide, forever, we're turning IE6 off. I don't know how we figure that out. I don't know if it's even legal to figure that out. But we have to do it. Somehow we have to find a way to do it. So on that happy note, I'm just going to make a plug. There are good parts in this language, and to use the language well, you really have to understand what they are and how to use them. So I wrote this cranky pamphlet from O'Reilly, explains the whole thing. Go check it out. Thank you, and good night.